Hi everyone, in this video I'm going to talk to you about arithmetic and geometric sequences. We're going to begin with just some definitions and notation. In general, a sequence of numbers is an ordered list of values where each number in the list can be found using some sort of method, pattern, or formula. We should pay attention to the notation for a sequence. The notation is usually a lowercase letter a, but it can be any letter with a subscript, in this case a sub n. That's notation that describes the term in the nth position. So the subscript tells you what position term you're looking at. So for example, if you take the sequence 2, 4, 6, 8, 10, and so forth, the third term in the sequence is 6. That's in the third position, 1, 2, 3. So we would say that a sub 3 is equal to 6. So we're going to begin with looking at arithmetic sequences first. So an arithmetic sequence can begin with any number, and that number can be any real number. We call this the first term, or a sub 1. In order to get the next term or the second term in the sequence, a real number is added to that first number. So that the number that is being added on is called the common difference, and we notate that as lowercase d. Then we continue adding the same value over and over and over again to get the remaining terms in the sequence. Here are two examples. The first example, this sequence is 5, 9, 13, 17, 21, and so forth. So in this case, a sub 1, the first term is 5. The common difference is the number that is being added to get from any term to the very next term in the sequence. And you have to be adding the same thing over and over again in order for it to be considered an arithmetic sequence. So here, to get from any term to the next, we are adding 4 every single time. So D, the common difference, is 4. And if we wanted to continue this pattern, we would continue adding 4. And the next 3 terms in this sequence would be 25, 29, 33, and that could keep going. In the second example, we're starting with 18. So a sub 1 is 18. But here you see the values are going down. So in this case, the value that we're adding is a negative number. You could also think of that as subtraction. So our common difference here would be negative 3. So we're adding negative 3, adding negative 3, adding negative 3. And if we kept that going, we would go down to 6, 3, 0, and we would keep going as long as we had wanted to for this sequence. So we don't stop at any particular number. Many times we see that these sequences are infinite. They go on forever and ever. But we have some ways that we can find a particular term in that sequence without having to list all the terms. So for example, if I wanted to continue this sequence but see what the 50th term in that sequence would be, I don't necessarily have to list out all the terms. We're going to come up with a formula in order to do that. All right, so to help you to understand the formula for the nth term, that's for any term in an arithmetic sequence, we're going to just start looking at some notation and use our inductive and deductive reasoning skills to help us come up with a formula. So the first column you see here is n. N is the position of the term that we're in. So this 1 stands for first, second, third, and so forth. The notation that we use in a sequence that we just talked about is a with a subscript. So a sub 1 represents the first term, a sub 2 represents the second, a sub 3, and so forth. A sub n represents what we call nth term. So that n is just a placeholder. It could be the 20th term, or the 100th term, or the 71st term. So we're going to think about what's happening in terms of our first term and that common difference d. So the first term is just the first term, that's it, a sub 1. But in order for us to get the second term, we take our first term, a sub 1, and we add whatever that difference is, whatever d is. So that second term can be written as a sub 1 plus d. Now the third term we get from taking the second term, so the second term is here, a sub 1 plus d, and then we add d on again. Now we could simplify this expression because we have two d's here. So we can rewrite that as a sub 1 plus 2d. To get the fourth term, a sub 4, we start out with a third term, which is a sub 1 plus d, and then we add another d on. If we simplify this expression, we have a sub 1 plus 3d. To get the fifth term, we add on yet another d. So this is what the expression would look like. If we're at the fifth term, we've added d on now 4 times. So we would have a sub 1 plus 4d. We could continue this pattern, but if you use your inductive reasoning skills, you might notice a pattern between the term that we're on, the number of the term, and the coefficient for d. Even if we go back here to the second term, a sub 2, we're adding 1d on. When we're at the third term, a sub 3, we're adding 2d on. So the number of d's that we're adding is always one less than the term number. That means if we're on a sub n, we've added d on 1 less than n times. Now that means if we were looking at the 20th term, a sub 20, we would have a 19 in the parentheses here, 20 minus 1. In the next video, I'm going to show you examples using this formula. So again, this is a formula for the nth term of any arithmetic sequence. I'm going to use it in the next video to find a large term in the sequence without having to list out all the terms.